Well, welcome back to Calculus. In a previous video, we looked at series and sequences, and I even asked you to take a look at a couple of different series and see what they did. So these were two of them from a previous video that we kind of started. I asked you to investigate on your own, and here I just thought I'd sit down and kind of run through these. If we're talking about this being a series, we're talking about the summation from k equal 1 to infinity of 1/4 to the n power. And we're going to compare that to the summation from k equals 1 to infinity of 5/4 to the k power. And I forgot that doesn't really look like a k there. That needs to be written as a k because I'm using k in my summations there. Now, what does that mean? What that means is I'm doing 1/4 to the first power, which is 1/4, plus 1/4 to the second power, which is 1/16, plus 1/4 to the third power, which is 1/64. And you just keep going on and on. Now, we can actually do these partial sums and find those partial sums do actually get really small, or they approach a particular value very quickly. And that's the idea behind this series converging. I encourage you to get your calculator out and actually do that process. Do 1/4 plus 1/16 and do 1/64, and then do the next one, which would be 1/4 to the fourth power, which is 256 at that point, right? 1 over 256, and just keep going and see what happens as you move further and further along. So you do the first one, which would be 0.25, and then you add the next one on there. So the next value, so this would be partial sum 1, so partial sum 2 would be 0.25 plus 1 over 16, and whatever that works out to be. And then just keep going and see what those partial sums, see how far you have to go out before you start noticing. Maybe you might need to get all the way out to 6 before you really start to see what's happening with that. This one's going to be a little bit different, though. So we have this one. What does this series look like? Well, this series looks like 5/4 to the first power, which is 5/4, plus 5/4 to the second power, which is 25/16, and then 5/4 to the third power, which is 1/25 over 64. And you can keep going on that one, but I don't need to go any further on this one because I have exactly what I need to point out to you as we run through this. This particular series does what we call diverges. In some instances, we actually can determine the series converges, diverges, or we don't know what it does. Those are actually three legitimate answers here. Normally, if we don't know, we try to do more investigation until we do know. But we don't know is normally a legitimate answer in this particular realm. But we do always want to try to do more if we can. All right, so 5/4, that is just a little bit bigger, so the numerator is just a little bit bigger than the denominator, but here when you get to 25 over 16, the numerator is almost twice the size of the denominator, and then when you get to 125 over 64, you're talking about it being, that is already to the point of it being roughly twice the size, right? So this is diverging because that value we're adding on keeps getting bigger, so the next term is bigger than the previous term, right? So because this term is bigger, right, than its previous term. And the fact that it gets bigger tells us that this is diverging. You're going from something that is just maybe 1.4 or something like that to being close to 2 at this point. Maybe this is 1.7 to something really, really close to 2. So these values may be actually going to somewhere. Like you could actually do the limit on this, right? We could say the limit as n goes off to infinity of 5/4 raised to the n power, and you could figure out what that value is, and maybe it goes to a particular value of some sort, but I don't, when you actually think about this and you stop, well, this is actually talking about being 1.25 raised to the n power. Is that going to go to a particular value, or is that just going to continue to grow and grow and grow? And it's actually going to grow. It's going to go off to infinity, which means that the values are getting bigger and bigger. So here are a place where we have two different fractions. Both of them end up giving us a sequence. We can find the partial sums of both of them. We can find s sub 1, s sub 2, s sub 3 of both of these sequences of A and B. But what we're going to discover when we start digging in on these two things is they give us very different behaviors. One of them is going to give us the behavior going to a particular value of some sort. All right, so we could actually find the entire sum of this other one here. Okay, of A is actually going to give us a value of some sort that we can find. We can find that value. This other one over here, well, it's just going to keep growing. So we can find the partial sums, but finding the sum, the complete sum, well, we can't do that because it's going to go off to infinity because we're always adding a bigger value to it. So anyway, I hope this was useful and helpful to you in your understanding of sequences and series, and I hope that you continue to dig in on this stuff and learn as much as you can. Remember, anytime you come up with an indeterminate answer, means you need to do more math. Take care.